Hey everyone, these are the notes for chapter 10.1 to 10.5. While that sounds like a lot, I do want to point out that this section is just a bunch of different applications for the same thing. So a lot of this is going to sound really similar, and skip through to the stuff that you might find unclear if you feel like that feels better. With that out of the way, let's get started. So I know that we've covered percentages in some capacity before, but when we talk about a percentage, that's just where 100% is the whole amount and a percentage is just a portion of that. Uh, Fun fact, the cent in percentage just means 100, which is why 100% is everything. So 78% really means 78 over 100, or 0.78. And since our number system is in base 10, if we want to get that 0.78, then all we'd have to do is move the decimal point over 2 places to the left. And that means we can take something like 64.2%, shift it over 2 points to the left, and now it's 0.642. And 640%, and that is allowed, 640% is just 6.40. I think every example and question in all of the homework and quiz and test are all going to be under 100%, but over 100% isn't inherently wrong. So I mentioned that a lot of this is just a concept that we're going to apply over and over and over again. And that concept is just increasing or decreasing a certain percentage in regard to some original amount. So we can talk about something like awesome chips coming in 2 sizes, regular and party. And the party size is just going to be 50% larger than the regular size. And that means in essence that when I talk about how much the party size has, I have an equation, which is the number of chips in the party size bag is just going to be the original bag number of chips and 50% of the original bag. So it's not 50% of the chips in the regular size bag that would mean it was smaller. It's the original plus 50%. So that's a 50% increase. For a decrease, we would do a subtraction instead. So let's look at some examples. We'll say that a bag of awesome chips is 600 calories and low-cal awesome chips has 25% less calories. So we can ask the question, how many calories does low-cal awesome chips have? And we've got that formula, just like before. This time it's going to be that the low-cal calorie amount is just the awesome chips calorie amount minus 25% of the awesome chips calorie amount. We plug in the values, we get 600 minus 25% of 600, which is just 0.25 times 600. So really that's 600 minus 150, which is 450 calories. We can also have a slightly different kind of version of this question, where we'll say that Awesome Chips actually sold 15,000 bags of chips, but this month they've only sold 13,000 bags of chips. So what's the percentage decrease from last month to this month? So just like before, we have a similar formula. In this case, we have this month's sales is equal to last month's sales minus some unknown percentage of last month's sales. Well, if you see, we have 13,000 equals 15,000 minus some percentage of 15,000. Well, we can subtract that 15,000 from both sides, and we'll get negative 2,000 is equal to some percentage of 15,000. Don't worry about the negative, that just means that it's a decrease rather than an increase. So here we then divide both sides by 15,000. And what do you know? That's negative 2 over 15, which if I then plug into a calculator is negative 0.133333, repeating, Then we convert it to a percentage because, well, we need it as a percent, and it's 13.33%. I rounded it at 2 decimal points, but technically it's 13.33333 forever. But, you have to round somewhere. Check the problem to specify how far. So next up, we'll have something that you should all be somewhat familiar with, which is sales tax. So this is one of the most common versions of a percentage increase, and it's just a percentage increase on the cost of an item. So we can talk about our awesome chips again, which cost $2.99 before tax. If the sales tax is 6%, then how much does the bag of chips cost? So the cost is just take the before tax price plus 6% of the before tax price. So in this case, it's $2.99 plus 6% of $2.99. And we're adding because it's a tax. It's an additional thing. So our cost is then $2.99 plus 0.06 times $2.99, which is just $3.17. I rounded it from 3.1694. And by the way, you should be familiar with this already, but if not, be aware that when we say the tax specifically, we're just referring to that small 18 cents difference. The before tax and after tax price are separate things. Again, this shouldn't be something that you're being exposed to for the first time here, but if it is, now you know. So next up, this is technically 10.3. We're just cruising along with commissions, where we'll say that sometimes for sales jobs, a person makes a commission, which is just a percentage of the sale on products that you happen to sell. So let's say that Nicole gets a 4% commission on all sales. If she sells $1,540 worth of goods, how much money is she going to make in commission? So all this means is that she takes that 1,540 and multiplies it by that 4%. And so that means that she makes $61.60 for selling the $1,540. It's kind of like a bonus for being a salesperson. Well, maybe Nicole wants to step it up. She doesn't want to make 61 bucks. She wants to make 100 bucks. So we can then ask, well, how much would she need to sell to get that? And in this case, it's a little weirder. We want $100. Well, that's got to be 4% of something. And, well, that means that 100 is equal to 0.04 times something. We're trying to figure out the something. So even though this is a little weird, we actually just have to divide by this percentage, well, the 0.04, on both sides to figure out what that mysterious term is, which if we plug into a calculator is $2,500. So if she sells $2,500 worth of merchandise, then success. She's made the money. She's made that $100. So that's nice. And then the last two sections in this are discounts and markups. Again, none of this is really a completely different process. This is just a different name for a different concept that uses the same kind of idea. So you'll probably have seen discounts and markups. Discount is something the store kind of advertises, and markups is the thing that they don't. Discount just means a percentage decrease. Sometimes it's a dollar amount, but we're thinking of this as a percentage. And a markup is a percentage increase. Usually this is in regards to the store buys the product for some amount of money, and then they need to sell it for a profit. So they sell it for more money, and the markup is the percentage increase. So, for example, we'll say a pair of jeans are being sold at a 40% discount. If I say the discounted price is 63 bucks, what's the original price of the jeans? Because oftentimes when we see discounts, we see the sale price and not the original if we miss one of the variables. So you might ask, well, how much were the jeans originally? So this is a little bit weird, and that's why I'm highlighting it, but it's still kind of the same formula. So in this case, we say that the discounted price is, in fact, the original price minus 40% of the original price. So in order to kind of like resolve this, uh, since we're trying to solve for the original price, we should probably combine it into one variable. So when, instead of thinking of it as the original price, we'll say that it's 100% of the original price, which is the same thing, because then we can subtract these percentages. In this case, we have the discounted price is actually 60% of the original price. Like if it's 40% off, then the remaining 60% is still there. That's a good way to think about it. But either way, when we then plug in our numbers, we have 63 is 0.60 times the original. So then we divide by that 0.60 and we get $105. So pretty decent deal. In this case, we could say that the discount was $42, but the discount rate was just 40%, which is kind of nice. So I might as well do an example with a markup. We'll say that Victor runs a furniture store, and Victor buys his tables at $300 wholesale, and then to make a profit, he's just going to sell them at a 45% markup. And we can ask the question, how much is he selling these tables for? And once again, the selling price of the table is just going to be the wholesale price of the table plus 45% of the wholesale price of the table. Wholesale, by the way, just means that he's probably not buying one table, he's buying a bunch of them and then getting a better deal on it. He's buying in bulk. And so then he sells it individual table to you, and he has to make some money on that, otherwise he kind of feels like he's wasted his time. So plugging in those values, we get that the selling price of the table is 300 plus 45% of 300, which is $435. So he gets to make $135, which is nice. That's his profit. So that's it. I know this seems like this should be somewhat long because this is technically 5 sections, but none of this really changes depending on the section. Like 10.1 is percentage increase and decrease, 10.2 is sales tax, 10.3 is commissions, 10.4 is discounts, and 10.5 is markups. The reason I say this is that the formula doesn't actually change. The vocabulary is a little different. The closest thing to a formula change is when we were talking about commissions, we just thought about the percentage change. We don't really add or subtract that, but it's just multiplying by a percentage, so not a lot more to say there. If you do have questions about this and you feel like this didn't explain a particular concept or something's throwing you off, feel free to send me a message via Canvas or email. You can also contact me during my office hours, which are Monday, Wednesday, Friday, 12 to 1. Also, if that doesn't work, send me a request for a different time and we'll meet up. I'll happily explain any particular question about this. This is also in regard to the previous sections. Any questions, I'll be happy to help. And with that, that's all I really have to say, so have a nice day.